Hi everyone, welcome back. Today we're exploring a new concept, wrapper functions. Wrapper functions are a way for us to easily change the behavior of a given input function. And one very common use case of wrapper functions is to time a given function. Let's say you're practicing for a technical interview and you are curious whether if two implementations to a given problem differs in runtime. One very easy way for us to check our implementation and compare their runtime is by creating a simple wrapper function that changes the behavior of your input implementation and print out the time taken to run that function. So let's quickly do that. So a very common question that you might encounter is checking whether if a string is a palindrome or not. A palindrome is a string where if you read it forwards and backwards, it will still be the same. So if you reverse abl, you will still get back the same string. So one way for us to quickly check if a string is a palindrome or not is to reverse it and compare it with the initial string. So let's say you come up with a simple implementation of that. So you have an input string and this function will return back a boolean for whether if it is a palindrome or not. The implementation can be input string equals to the reverse representation of this input string. So this implementation is nice and all, but if we are given a very long input string, but the edges of the input string are already not equal to one another. So the starting character is not equal to the ending character, and it's pretty clear that this string is not a palindrome. This current implementation would be inefficient. It would reverse the whole string anyway, taking up on time, where n is the number of characters in your input string. So this is not ideal. And let's say you have a second implementation, is palindrome, but we do a linear scan instead. So you have the input string, but instead of reversing the string here for the implementation, you have a left and right pointer pointing at the edges of your string. You compare the contents of both pointers, and if they are the same, you will continue the search towards the center. You will move your left and right pointer towards the center, and if at any point of time the characters are not equal to one another, you will terminate the loop and return back a false. This will be more efficient compared to the one that we just came up with the reverse strategy. So let's say you have a length. This will be the length of input string. And let's say you do a linear scan like this. So now for left in range length, and we floor the division by 2 because we'll be moving the left pointer from the edge towards the center. Then you will define your right. This will be equals to length minus left, minus 1 minus left, because it's 0 indexed. And if the input string left, if input string left is not equals to input string right, you return false. You will terminate the search because it's not a palindrome, otherwise return true. So these two implementations work. Let's quickly test this out. So this is the string. This will be equals to ABC multiplied by 1000, and we will print out is palindrome reverse and is palindrome linear scan. And let's quickly check if this implementation works. So both return false. Let's try a string that is a palindrome, let's say A, and both return true. Everything looks fine. So if we wanted to test out how both implementations behave, how long each of them would take, we can use the datetime library. From datetime import datetime. We can do the start. So let's say start datetime equals to datetime.utc now. This gets the current time in UTC, and this is the end. Okay, datetime.utc now. We can check whether if the first implementation takes whatever time by printing out the difference between them. So let's say is palindrome reverse took n minus start microseconds. That's one way. and we can copy and paste the implementation, these lines that we added to check how long each of them take. So this is one way we can do it, but as you can see, we are repeating the logic of timing a function. So that is one way we can reduce the code duplication here, and one way is by using wrapper functions. So we can define a timeit. This timeit function over here will take in another function, and this function will take in a callable. The callable is a type hint for functions, and from typing import callable and any. In this case, the function can take in any number of inputs. So the first type hint over here is a list of any number of functions, and let's accept any function that return anything, and we will return back a callable of the same type like this. So we can define time func, and this time func will take in a certain number of arguments and keyword arguments. Different functions take in different numbers of arguments and keyword arguments, so we are taking in all of those arguments and keyword arguments that the function would read in anyway. And we will similarly do start datetime equals to datetime.etc. Now we're getting the start time before running the function. We run the function that was passed to us, and we pass in the arguments and keyword arguments that we might have, and we define the end time as what we did below, and we will print out the function. So let's say func name took n minus start microseconds, and we will return back the result, and we will return the function that we just edited the behavior for. So we have created a new function where we get the start time, the current time that we have right before we run the function. We run the function and we get the end time and print out how long this takes. And just like that, we have created our own wrapper function that takes in any function and wraps a function so that we can get the time taken to run that function. So how we will use this function is by using the add decorator like this. So by decorating the function with timeit, we are changing the behavior of these functions over here. So implicitly under the hood, this is just syntactical sugar for passing this function into this function that we define on line 9. So now we no longer need to do these code duplications. These functions, when executed, would print out the time taken for this by itself. So we will try running this again, and as you can see, we printed out the time taken for the function. So that's a very neat way for us to use this simple wrapper function to test out how long each of our implementations for functions take. So that's pretty much it for this series. I hope that you found this sharing of wrapper functions useful. And if you like this series, please give us a like and subscribe, and we will see you in the next video.